Hi everyone, so let's talk about the Chatelier's principle, shall we? It states that if a system at equilibrium is stressed, the reaction will proceed in a direction that will counteract that stress. So equilibrium means that the rate of forward reaction is the same as the rate of reverse reaction. Okay, so what is stress? Well, there's three main types of stresses. It's the change in concentration. So we can see this usually by the change in color of a chemical reaction. The changes to the pressure in a gaseous system. So if the pressure decreases, the volume is going to increase and vice versa, right? And then changes to temperature, if there's heat, you want to move to the place where there's less heat and so on. I'm going to touch more upon this later, so don't be so stressed out about the stresses. Haha. Okay, so I have a reaction at equilibrium, so the hardy faces are the reactants and the sad faces are the products. So in this state, this is in equilibrium, but if we suddenly add the two hardy faces, it's not going to be at equilibrium, right? So this is a problem because we have to make it into an equilibrium state back again. How do we do this? Well, we just add the sad faces to compensate for the two hard faces that emerged before. So now the equilibrium is restored. So we say that the equilibrium moves to the right because the sad faces in the right were added. So that doesn't mean that if the concentration of the reactants increased, the equilibrium moves to the left. It actually goes the opposite way, and that's what Le Chatelier said in his principle. Okay, so let's go to changes in concentration. We have a reaction. So what happens if we add iron chloride? Well, if we add iron chloride, the concentration of the iron ion will increase. So what does that mean? Well, we have to compensate for this reaction. So we're going to increase the amount relatively for the thiocyanate iron. So this shows that the reaction moves to the right and the concentration of the thiocyanate iron is going to be more concentrated, so the reaction will be more red. Okay? Now let's talk about the changes to pressure in a gaseous system. So changes in pressure. We have nitrogen gas plus 3 hydrogen gas, 2 moles of ammonia. This is following the Haber process. So what happens if we increase the pressure? Well, the volume will decrease. Now, Le Chatelier's principle states that the reaction proceeds to a side with a lower number of particles if there's an increase in pressure. And that makes sense because an increase in pressure means less volume, which means that you want to go to the side where there's less space, right? Okay. Now let's talk about the changes to temperature, and this is the last part of this video. Yay. Okay, so we have iodine, right? Not iodine, right? Okay. Iodine plus chloride will give us 2 iodine monochloride, and this is an endothermic reaction because we have a positive delta H value, and it has a delta H value of plus 35 kilojoule per mole. Now, in my definition of equilibrium, it's stated that the rate of forward reaction is the same as the rate of reverse reaction. So what it means is that the rate of forward reaction is the reaction that's going to the right, and the rate of reverse reaction is the reaction that's going to the left. So the arrow that points to the left is the rate of reverse reaction, and in this case we see that the rate of reverse reaction is an endothermic reaction. Le Chatelier's principle states that the increase in temperature will favor the endothermic reaction and the decrease in temperature will favor the exothermic reaction. So what happens if we increase the temperature in this equilibrium formula? Well, it favors the endothermic reaction, right? Because if you increase the heat, then it's going to want to go to a place where there's less heat. So it's going to go to the side where there's an endothermic reaction. So it means that the equilibrium will proceed to the left. Okay guys, so I think that's it for Le Chatelier's principle. That is it for Le Chatelier's principle. And the dinosaur is moving to the left like the reaction before moved to the left to the endothermic reaction. Okay, see you guys next time. Bye!